determine the proper grounding conductor size for parallel service feeds from the secondary side of a 277/480 volts transformer going to a 3000 amp switchboard, consider these steps. The conduit is run in 8 parallel polyvinyl chloride feeds with 4 500 mcm conductors in each conduit. Firstly, calculate the ampacity of the conduit group. The ampacity of the conduit group is the sum of the ampacities of all the parallel conductors. There are 4 conductors in each conduit. The conductor size is 500 mcm. The ampacity per conductor is 380 amps, assuming THWN conductors in polyvinyl chloride conduit. Therefore, the ampacity of the conduit group is 4 times 380 amps, which equals 1520 amps. Secondly, determine the grounding conductor size. The grounding conductor size is based on the ampacity of the conduit group. For service feeders, the grounding conductor must be sized as follows. For conduit groups with an ampacity of 1000 amps or less, a 1/0 American wire gauge grounding conductor is required. For conduit groups with an ampacity greater than 1000 amps, a 3/0 American wire gauge grounding conductor is required. Therefore, the proper grounding conductor size for this installation is 3/0 American wire gauge. Thirdly, verify the conduit size. The conduit size must be verified to ensure that it can accommodate the grounding conductor. The 3/0 American wire gauge grounding conductor has an outside diameter of approximately 0.56 inches. The conduit must have a minimum inside diameter of at least 1.25 times the diameter of the grounding conductor, which is approximately 0.7 inches. Since the polyvinyl chloride conduits used in this installation have an inside diameter of 3.23 inches, they are sufficiently sized to accommodate the 3/0 American wire gauge grounding conductor. Note that the minimum conduit size for the 500 mcm parallel conductors is also 3.23 inches. Therefore, the chosen conduit size is suitable for both the phase conductors and the grounding conductor. In summary, to properly size the grounding conductor, you need to calculate the total ampacity of the parallel conductors, determine the required grounding conductor size based on that ampacity according to the National Electrical Code, and verify that the conduit is large enough to accommodate both the phase conductors and the grounding conductor.